Everyone, my name is Temitope Omowumi. I'm an advisor on electrification planning at the Nigerian Energy Support Program. And this is just a brief about me. Like you saw on the title screen, the title of this presentation is Data-Driven Geospatial Electrification Planning. To look at how GIS and geospatial is also helping in international developments, especially in the area of access to power. So this is just a brief about me. I have a background in civil engineering, GIS, as well as data science. I have professional experience in civil engineering, telecommunication, and power. I currently work as an advisor on electrification planning at the Nigerian Energy Support Program by GIZ Nigeria. I will talk more about the program in the next slide. This is just the outline of what I want to present today. Just a bit of introduction about the Nigerian Energy Support Program. The Nigerian Energy Support Program is a technical assistance program by the German federal government to the government of Nigeria, and it is commissioned by the European Union and the Federal Ministry of Economic Cooperation to the tune that you are seeing on my presentation. It is implemented jointly with the Federal Ministry of Power, and it is implemented by my company. It has an overall objective to promote investment in domestic market for renewable energy, energy efficiency, and electrification in Nigeria. So in the upcoming slides, I'll be showing how we are using geospatial technology and methods to achieve this and the impact we are having. This is just an overview of the program. It has three main topics that I focus on. As you can see, we have a component on electrification planning, sustainable energy access, and enabling environment for renewable energy and energy efficiency. So I will show you what we do in electrification planning and our activities, how we use geospatial. And most importantly, we also have a product that we call the Nigeria NESP for All platform, which is actually a geospatial tool that is live on the web that can be used for planning, especially off-grid electrification projects and similar. So this is just a kind of overview on what we do in electrification planning. We champion these three things, which is data collection, dissemination, analytics, dashboards, as well as capacity building in the topic of data and geospatial geospatial skills in order to achieve our targets. So just to expatiate a bit on what we do in the area of data collection, which is purely geospatial data. So it's GIS, as we all know, is the science of where, and so we do a lot in collection of data on where people live, how they live, where the grids are, the quality of energy supply, and all these data points are all geospatial data points, which means they are tied to location information and they are spatially accurate. We use some of these measures. We use AI and satellite imagery. We do physical tracking. We also use remote mapping using GeoSM and similar things to contribute objects in OpenStreetMap. We also have site surveys, and we also collect using measuring device, sometimes telemetric device as well, to remotely collect supply information on specific area in order to also just not know where those things are, to also know how, on the conventional grid, how power is being supplied to these locations. So this is some of the geospatial processes that we apply to actually using satellite imagery and some basic scripts to actually auto-identify the entire building footprint, settlement footprint in Nigeria. So we applied this model that auto-classify settlement pre-tree, because when we started out initially, it was even very difficult for us to even know where we could get settlement clusters, which will be the basis to then, either reference other elements geospatially to account for either their power or how to get power to this area. So we use this. We can, if you visit our platform, you can see more on the processes. And like I mentioned, we also use a lot of desktop heads-up mapping using GeoSM and OpenStreetMap as well to then contribute features, building routes, trees, to map each of these communities and contribute data into OSM database, because OSM is a large part of the work we do. And I think some of our people that contributed on some of our projects are on the leaderboard for OSM in Nigeria, even maybe in sub-Saharan Africa. We have people that have contributed hundreds of thousands of elements to the OSM database. And then as well, we also do a lot of geospatial grid collection. We have using mobile devices as well as mobile mapping rigs. We have 2 mobile mapping rigs that was deployed in the program. This was targeted towards actually mapping grid infrastructure as they are, because in most cases in Nigeria, what was existing before was that even the existing grid in places where the grid was present, they were not geospatially mapped and put into any databases. So it was a bit difficult to then reference the extent of the grid to know the last mile where the grid is to maybe off-grid communities or places that have the grid and they do not have adequate supply, and different scenarios that occur in the, in the business of power supply. So we have these mobile rigs. As you can see, they are advanced. They are made by Trimble, and you have a backend whereby after the field run, you take it back and image extracted and all the features that you see. I'm sure if there are people on the call that understand mobile mapping, the Trimble offering, and there are also other OEM that have different offering in mobile mapping. It just means that there are these 360-degree cameras that we traverse around, and especially it's more efficient and time-saving in collecting existing infrastructure, lines, poles, electrical elements. So this is part of what we do in data collection. And I also mentioned capacity development. So we have curriculum on spatial application tailored mostly to power supply and electrification. And in these measures, we have in-person trainings. We use virtual and e-learning. We also have mappathons, which I'm sure maybe some of the people on this call knows about some of our mappathons that have been organized over the years. I think over the past 2 years, we've organized close to 15 mappathons, whereby we select off-grid communities to contribute using OSM and GeoSM to contribute to the database of these places, buildings, and the rest. And these are the people we target with our training. Public sector partners like Ministry of Power, Rural Electrification Agency in Nigeria. We also do a lot of work with private sector, especially those that develop small power solutions for off-grid communities, as well as targeting university students and young professionals. And this is just some of the content of some of our training. So just to showcase some of the things we've been able to achieve in terms of promoting geospatial data collection, open data, and putting them into places where they can easily be accessed openly. So in terms of collecting the grid, we focus on the medium voltage grid in Nigeria that covers the 11 kV and the 33 kV, which is in between the transmission and the last mile, because we felt that's the most critical level in grid supply, whereby if that level is present, there is more chances that you can get power. It just needs to be stepped down once more and you get connected. So we've actually collected 60,000 kilometers plus of the grid in Nigeria across 22 states. And I think from estimations, we have 100,000 plus grid 100,000 plus kilometers of grid in Nigeria, which means we've actually covered 60% of the grid in this program over the past 3 years. In terms of off-grid community visits, which is when we have boots on the ground. We went to do site assessment for communities to the tune of 700 plus. In terms of mapping, OSM mapping, desktop mapping, we've been able to map in over 3,900 communities in Nigeria. And in terms of building count, our contributors to OSM have contributed 3.2 million buildings to the OSM database. So that is what we've been able to do in the area of grid collection. But as part of what we also did, I did mention initially that we have this geospatial planning platform that was built. It is called the Nigeria NESP platform. I have a slide after here whereby the functionalities of this platform will be a bit more elaborated upon. We also make map products, as you can see, that are made into hard copies, and you can also find them as PDF. These are more like site perspectives that showcases off-grid communities that have characteristics that are economically viable to put off-grid renewable technology with things like mini grids that are powered by PV, which is solar, or it could also be other kind of technology, especially if they are competitive, they have competitive advantage in maybe small hydro, or they are very close to maybe the south of Nigeria with a lot of oil installations where they can then use maybe like gas powered solution that is not connected to the main national power supply, but it's more of a decentralized solution for them. So this kind of products are also part of what we have been able to come up with in the program. And these are just what even an investment specialist who is not necessarily a geospatial specialist can really look at the number of buildings there, commercial users, public users, and similar. So then this is our work on data collection mainly, and the products we have. So we now have this platform, which I also want to quickly showcase in my time. I don't know who is tracking the time. If you can tell me how much time I have left, please.
You have only a minute left.
Oh, wow. Okay, so the Nigeria Energy Supports platform, the Nigeria NESP platform, we call it an energy information system of some sort, whereby it collects, analyzes, and disseminates data around energy information. And this is geospatial in this. I will just run through it. So these are just some of the attributes that this platform has. This is the URL to visit the platform. It has many components. We have a GeoNote content manager that houses data, and we also have web apps that were developed for 3 different technologies. Let me just showcase it. We have technologies around mini grid, we have technologies around solar home systems, and we also have topics around the conventional power system. So when you go to this platform, it gives you customized solution for the kind of technology you want to focus on, and also it screens the data from the data content management system to what is relevant to that technology, and you can quickly, be able to do some basic analytics for you on the platform. We also have additional material, and if you want more information on this platform, you can reach out to me or visit on your own. So this is just an overview of the platform. As part of, this is just a short video, but I don't think I have time to do the video. But we also have what we call a monitoring and evaluation platform to track and see the performances of off-grid solutions in technical, financial, and social dimension. So it has a dashboard, and when you go into a specific site, you are able to see the parameters of the site, you are able to see the site on a map, and you're also able to see the performance of the site based on the criteria that is being used to track the site. So I also mentioned, as part of our e-learning, our capacity development as well, we also kind of built an e-learning solution where you can do course on demand on some geospatial topics, surely tailored towards electrification as well. So that is the overview of the Nigeria ST for All platform, which I wanted to showcase in this my talk. So that would be the end of my presentation. If you have additional questions now, you can ask me. And if you want to know more about this platform, you can reach out to me through my contacts. Thank you very much.